Welcome guys to my channel. This is Chemistry with Min. Today,
Hello guys, today we'll be talking about chemical reaction. Okay, so let's get started. So what is a chemical reaction? A chemical reaction is a process in which one or more substance, the reactants are converted to one or more different substance, which is the product, and the substrates are either chemical elements or compounds. So this is one of an example of a chemical reaction. So we have a reactant and a product. So what is a product and a reactant? So a product is a substance that is present at the start of a chemical reaction. This one. And then the product is the substance that is present at the end of the reaction. Okay. So before we move forward, let's discuss the different symbol used in chemical equation. So if you hear a plus sign, it is used to separate the reactant or the product. Arrow, it means yield. It is used to indicate the result of the reaction and separates reactant from product. If you see a double reversible sign, it means the chemical reaction can be reversed. So if you see a S sign, it means the substance is solid. If L, liquid, G, gas, and AQ is aqueous solution. So if you see a delta sign, a triangle, it means that the application heat to the reactant. And then if you see an up sign, it indicates of a state that changed into gas. While downward sign indicates a precipitate formed by a reaction. So let's move forward to next topic. Types of chemical reactions. There are four main types of chemical reaction: synthesis, decomposition, single replacement, and double displacement. Um, for easier understanding of uh, this part, remember synthesis, you're getting married, while decomposition, you're getting a divorce. Why? In single displacement, because your partner cheated. And then the double replacement, you had a switch of partners. So again, synthesis, getting married, they're combining the two of you. Decomposition, they got divorced. Single displacement, because one partner cheated. And double replacement, these just switch partners. All right. Let's dwell deeper to the topic. So synthesis is two or more chemical bonds together forming one substance. So you can see here, like I mentioned a while ago, getting married. So the reactant from the beginning will combine together to make a product. So A plus B will turn into AB, or C plus B will turn into CD. The composition or the divorce is one substance breaks down into or more separate substance. So they're getting divorced. So for example, we have a reactant AB, and then it will break down into A plus B. So in chemical example, we have two two hydrogen hydrogen dioxide will decompose into water and oxygen. All right. Next, single replacement. One element knocks another element out of a compound. So remember the cheater. example, you have a GF, and your GF and your BF or your partner, whichever you like, cheated to another man or woman. So you're now together and you are left alone. So you can see here, single replacement AB plus X is equal to A plus AX plus B, or AB plus X is equal to BX plus A. While double replacement, two compounds switch ions with each other. So this is one of the examples. In the reactant, we have barium chloride plus sodium sulfate. So sodium sulfide. Sodium sulfate. Sorry. Now it turned into barium sulfate plus salt or an sodium chloride. We just switch partners. See? Ba got this and Cl got this. And combustion. Everybody loves oxygen. A compound burns in oxygen gas. So fuel plus oxygen is a combustion. So this is one of the example which is methane. Methane plus oxygen will yield the product of carbon dioxide plus water. Okay, let's try this one. Let us try and tell me what type of reaction is this. So what can you see here? They're getting married. So this is synthesis. This one, they're getting a divorce. See, they're splitting up. So this is decomposition. This one, they're switching partners. So it would be single replacement. This one, they're switching partners. So HCl will combine to hydroxide, and then Na or sodium will combine to Cl. So this is double replacement. And this one, since it's fuel plus oxygen, this is combustion. There you go. Now, what are the factors that affect the rate of reaction? The size of the particle of a solid reactant, the concentration of the reactant in the solution, temperature, the addition of a catalyst, and the nature of reactant. So the nature of reactant determines the amount of the activation energy or the height of energy barrier that must overcome in order for the reaction to take place. So low activation energy occur rapidly, in higher activation energy occurs slowly, and ionic reactions occur rapidly, and covalent reaction occurs slowly in terms of rate of reaction. So next, the size and particle matter. The smaller the particles, the faster the reaction is, because the more surface area, so the more chance of collision. So the concentration of the reactant, the more particles there are of a substance in a given volume, the more chance they will collide. So the more concentration that you have, the more chances that they will collide, thus increasing the speed of reaction. Temperature. So the more particles, the more energy that the particles have, the more they move around. And the reactant has an increased chance of collision. Meanwhile, if you slow things down, they're less likely to collide with one another. And lastly, catalyst. A catalyst is a substance which can speed up the rate of a chemical reaction without being used. So if you add a reactant, if you add a catalyst, will increase the rate of reaction. So let's move on to the mass of conservation. So the law of mass of conservation in a chemical reaction, matter is neither created nor destroyed. So in other words, the number of and type of atom going into reaction must be the same as the number and the type of atoms coming out. So if the equation obeys the law of conservation, it must be balanced. So for example, this is an unbalanced equation. So we have one carbon, four hydrogen, and two oxygen. And in the product side, we only have one carbon, two hydrogen, and three oxygen. So what shall we need to do to make it balanced? Because hydrogen and oxygen are not balanced in the reactant and product side. So we will add two oxygen and two in the water side. So here's the rules of the game. In order to balance, matter cannot be created or destroyed. Subscripts cannot be added, removed, or changed. So again, what is a subscript? This is a subscript, and you can only change the coefficient here, and here, and here. But this is a subscript. You cannot change that. The coefficient can only go in front of the chemical. Formulas never in the middle of the formula. So extra tip. Try balancing big formula first. Save the free element for last. If the same polyatomic ion appears on both sides of the equation, it's usually okay to treat them as one unit. There is no one particular way to balance equations. Some equations are harder to balance than the others and might require some creativity. So let's try something here. So is this equal nitrogen and hydrogen to create ammonia? Yeah, to create ammonia. All right. So you have two nitrogen in the reactant, two hydrogen in the reactant. Well, in the product, we have one nitrogen and three hydrogen. So how we will make this equal? So we need this to become 2. So now it's equal both ends, but this turned into 6. So how we will make this equal to this side? We will add 3 here. See? If you do that, it will become balanced. Okay, let's try another one. Oh, okay. It's already balanced, but yeah. See? It's already balanced. You need to have, okay, this one. You need to, we have only one potassium, one chloride. It's balanced. However, the oxygen is not balanced. What was, what shall we do to make it balanced? All right. So we need to add 2 in both sides and and 2 to the oxygen. 3 oxygen and 2 in potassium chloride. So to make it equal. So let us try to balance some more. What is stoichiometry? Using a balanced chemical equation to determine how much reactant or product is consumed or produced in a chemical reaction. So you need to remember this table in order to solve stoichiometry. At least familiarize with this. So basically, gusto mong makuha yung moles ng chemical B using chemical A or yung reactant or product. So let's try some problems. So mass to mass problem. So propane undergoes combustion with oxygen to produce the and water, carbon dioxide and water. What mass of CO2 is produced during the combustion of 18 grams of propane? So this is the propane and this is the carbon dioxide. So we want to know kung ilang oxygen ang maproproduce using 18 grams of propane. So let us try to solve this. So una, isi-set up natin yung equation. So gusto natin i-set up yung equation, right? So, in order to solve this equation, so kailangan natin i-set up muna siya. So, paano natin mas-set up? So, alamin muna natin kung ano gusto mangyari. So, di ba gusto niya maging yung propane, which is gram, gram C380, propane, gram, to CO2, gram. Para mangyari yan, kailangan natin dumaan dito. CO2, 8 grams, mole nito, and then, ito yung mole A, mole A natin. Then, mole B, and C. So, let us set up the equation. Pero sa diagram, ito yung itsura niya. So, nandito tayo ngayon, given in grams. So, i-convert natin yung grams to mole. Pag nakuha na natin yung mole, ikukunin na natin yung mole B. I-convert natin using ratio. And then, i-convert back natin to grams. So, pag ganun yung step. So, moving back. So, let us set up the equation. So, we have 18 propane times 1 mole of propane. So, ang molar mass niya is 44 grams times 1 mole of C3H. Bakit 1 mole? Kasi isa lang siya, oh. And then, ilan ang mole ng carbon dioxide? 3. So, 3CO2 times, ano yung molar mass ni CO2? 44 grams of CO2 divided by mole. So, pag minultiply natin lahat yan, makakaproduce tayo ng 58.2 grams of CO2. And that would be our final answer. So, paano nangyari yan? Gram, mole, mole, to CO2. So, another one. Let's try another one. So, you have 30 grams of methane that you want to burn in oxygen. How much grams of water can you make? So, gusto natin i-convert ito to this. So, ano itsura niya sa equation, sa graph? Ganito, meron tayong given, and then, convert natin ito into mole, convert natin into mole to another mole. Okay? So, let's get started. So, meron tayong CH. 4 gram G to CH4 mole to H2O mole to H2O gram. Yan. So, let us set up the equation. So, 30, yan, 30 grams yan, times 1 mole of CH4 divided by 16 grams. Saan galing ang 16? Molar mass nito, guys. Molar mass. Times, ilan ang hydrogen natin? 2. 2 moles of hydrogen divided by 1 mole of CH4 times 18 grams of water divided by 1 mole of water. So, what would be our final answer? Would be 67.5 grams of H2O. There you go. So, paano naman ang problem natin ay mass to volume? So, sa diagram na to, mass to volume. So, ito yung magiging problem natin from here to here. Mass to volume. Here to here. So, let's get started. So, what is the volume of oxygen at standard temperature and pressure can be formed from 50 grams of potassium chlorate? So, ito yun. Gusto natin ma-convert ito to potassium chlorate. 50 grams of potassium chlorate to oxygen volume. So, ang mangyayari dito, 50 grams, mole, volume. So, let's set up the equation. So, may 50 grams of potassium chlorate tayo. Potassium chlorate. Sorry. KCl3 times 1 mole of KClO3 divided by anong molar mass nito? 122 grams. Ang molar mass nito, guys. There you go, 122 KClO times, ilan ang, ano natin? Dalawa. Dalawa ang potassium chlorate natin. Ilan ang oxygen natin? Tatlo. Then, ilan ang molar mass ng oxygen? 18 grams. Sorry. Ilan ang volume? Remember, ang standard volume nito is 22.4 liters over 1 mole of oxygen. So, ang final answer is 13.8 liters or 13.8 liters of oxygen. There you go. Next. Let's try another one. How many, same pa rin yan. Gusto nga i-convert, how many liters of oxygen are needed to react 0.234 grams of sulfur dioxide gas? So, in STP. So, let's set up the equation. So, gusto natin grams of S2O4 to mole of S2O4 to mole of oxygen to volume of oxygen. There you go. So, set up equation. So, we have 0.234 grams divided by 64 grams. Molar mass nito. Divided by 1 mole times ilan ang mole nito? Dalawa. 2 mole. Ilan ang mole nito? Dalawa rin. Oxygen pala. Ilan ng oxygen? Isa. Mole. Times. Ano ang molar mass ng oxygen? Anong standard, standard pressure? That's 22.4 liters over mole. So, our final answer would be 0.00409 liters of oxygen. That is our final answer. So, let's try another problem. Volume to mass. Okay. How many grams of aluminum must react with sulfuric acid to produce 1.25 liter of hydrogen gas at standard temperature and pressure? So, gusto natin, ma-convert si hydrogen gas to hydrogen gas na volume to let us set up the equation. Ilan ang liters? So, 1.25 liters of hydrogen times 1 mole of hydrogen. So, 22.4 liters per hydrogen times ilan ang mole ng hydrogen? Tatlo, 3 mole of H2. And ilang mole ng aluminum? 2 aluminum. Times, ilan ang molar mass ng aluminum? 27 grams of aluminum divided by 4. So the final answer would be 1.00 gram of aluminum. And that would be our final answer. So ano itsura niyan sa graph? So ito yan, volume. Gusto natin maging volume ng hydrogen yung product papunta dito. Pag ganon. Okay? Gets? So last problem that we'll solve today. Oh, nasolve ko na pala. Okay. Nasolve ko na pala. Never mind. Okay. Let's move on to the next topic. Okay, guys. Let's talk about limiting and excess reagents. So, let's have an example here. How many cookies can I make? So, meron tayo sa pantry ng 10 cups of flour, 12 eggs, 5 cups of sugar, and 10 cups of water. So, para makagawa tayo ng 12 cookies, kailangan natin ng 5 flour, 2 itlog, 3 sugar, and 2 tubig. Ilan ang pwede nating magawang cookies? So, kung mapapansin nyo, isa lang ang pwede nating magawa dyan. Tapos, marami tayong magiging tira. So, ilan ang magiging tira natin dito? 5. Ilan ang matitira natin dito? 10. Ilan ang matitira natin dito? 2. Ilan matitira dito? 8. So, sa itong natin, makagawa pa ba tayo? Hindi na. Dahil kulang na tayo sa asukal ng 3 cup. Ayan ang definition, ayan ang analogy sa gagawin natin ngayon. So, important terms that you should know. Limiting, reactant that limits the amount of product produced in a chemical reaction. Siya yung least amount of product magagawa. While yung other reactant is not completely consumed, ang tawag doon excess. So, sino ang limiting reactant dito? Si asukal. Sino naman ang mga excess? Si flour, eggs, and water. So, theoretical yield, the amount of product that can be made in a chemical reaction based on the amount of limiting reactant. So, let's try some problems. So, carbon dioxide and chloride oxide is a reactive oxidizing agent. It is used to purify water. So, ito yun. Chloride dioxide. Chloride dioxide is a reactive oxidizing agent. It is used to purify water. So, ito yung equation. So, gusto natin malaman kung ilang sa 71 grams of chloride dioxide at pinaghalong 19 grams of water, sino ang limiting agent? Si chloride or si water? So, check natin. So, ang gagawin natin, yung 71, i-divide natin sa molar mass nito. At yung 19, i-divide natin sa molar mass ng water. Kasi yun ang given kanina, di ba? So, yun. Pag dinivide na natin siya, sino ang mas mababa? Si chloride, chloride dioxide, or si water? Mas mababa si water, di ba? Pero hindi pa tapos yung ano natin. Ngayon, i-multiply natin siya sa number of moles ng gusto nating i-react. Di ba gusto nating i-react si HClO, hydrochloroxide or yung acid. Ilang acid ang pwede nating i-ano. So, meron tayong 6 dito and 3 water. So, i-divide natin to, yung mole, yan, i-divide natin siya. So, 1.056 divided by 6 yung kasing mole para makuha natin yung amount ng HCl. Ganun rin gagawin natin sa water. So, sino mas mataas? Si water or si chlor si chloride si chlorine dioxide. So, ito ang mas mababa compared kay water. Siya yung limiting reagent. Now na alam na natin limiting reagent, ang hinahanap naman is ano ang mass na expected natin. I-multiply natin siya sa naging result natin sa limiting reagent. So, yan, ito yung equation. And then, i-multiply natin sa, yung kung ano nakuha natin dito, yung i-multiply natin sa molar mass. Okay? And then, how many molecules of HCl are there in part A? So, ito yung gagawin natin. Remember pa ba kung paano mag-convert ng molecules? So, that's that. And then, lastly, percentage yield is the amount of product calculated through stoichiometric ratio or the maximum amount product that can be produced during the reaction and thus it's called theoretical yield. And the actual yield, yung amount of product in a chemical reaction, it is actually the amount obtained from the reaction. So for example, ito yung formula. Actual yield divided by theoretical yield. Para makuha natin yung percentage yield. Let's have an example. So in an experiment forming ethanol, the theoretical yield is 50 grams and the actual yield is 48 grams. So ano yung percentage yield? So i-divide lang natin si 46 divided by 50 times 100. So 92%. So that ends our lecture. So I'll try to upload more examples for the reactant and